Right, so now we are going to talk about converting from a recurring number to a rational number. Now, it's very important that I review what we talked about for rational and irrational numbers. With rational numbers, it's a number that can be written as a fraction. So, given any number, if you can write it as a fraction, then it is rational. Now, we also went on by saying that what is a fraction? How do we define a fraction? We said that a fraction is an integer over an integer. So if you were given the square root of 3 over 2, although you see the fraction bar, although it resembles a fraction, it is not a fraction because by definition, a fraction is an integer over an integer, right? That's very important. And we also said that in order for you to come to that conclusion, you have to make sure that the number is in the simplest form, because that's only when you can draw that conclusion. Because sometimes it could be given 0.5 over 2, and that will simplify to 1 over 4. And since 1 over 4 is an integer over an integer, therefore 0.5 over 2 is actually a rational number, right? So those are some of the things that we talked about in grade 9. When we come to grade 10, I gave you two more definitions. I gave you some more properties that we can use to identify a rational and irrational number. I said that rational numbers are terminating, means that it stops, it ends. And I also said that rational numbers are recurring, meaning that there's a set of numbers or a single digit that repeats after the comma. It repeats continuously. For irrational numbers, I said that irrational numbers are non-terminating, meaning that it goes on, it continues, there's no end. And I also said that they are non-recurring, means it repeats after the comma, but there's no pattern. Right? I hope you understand that. So let's read. Decimal numbers can be recurring, non-recurring, terminating, or non-terminating, and can represent both rational and irrational numbers. Very important. Exactly as I just explained at length now. We must understand decimal numbers because this will help us identify if a number is rational or irrational because of its properties above. Again, looking at a number like 0.5, because it ends, then we can say that it's terminating, then we can say that it is rational. That's why understanding decimal numbers are so important. Decimal numbers consist of two parts, a whole number part, which is to the left of the decimal point, and a fraction of a whole number, which is the fractional part. This is to the right of the comma. And these parts are separated by a dot or a comma. Decimals can be equivalently represented as a fraction. So you can take this and represent it as a fraction. Decimals become more significant once we add a unit of measurement attached to it. For example, if we speak about 1 1/4 centimeters, this would be 1.25 centimeters. Practically speaking, let's say that you go to the hardware store and you purchase a pipe. You would ask for 3/4 inch pipe. 3/4 inch would be 0.75 inch. What this basically means is that you're taking 3/4 of 1 inch, right? Of 1 inch. So if you have to convert this into centimeters, this will be 3 over 4 of 2.54 centimeters. So of one whole inch, of one whole, let's say, pizza, you're taking 3/4 of that. But in terms of this here now, putting it more realistic example, you're saying that you want 3/4 of that, so it's a fraction of that. And that is approximately 2.2 centimeters. Okay, that's basically what we're saying. It makes more sense when you talk about it in a practical sense. So the fractional part represents 3/4 of a whole inch. Okay, or you could say you want, or you could ask for half a loaf of bread. So it's half parts of a whole loaf. Right? You understand? If you visualize what I'm saying, you would understand precisely what I am saying. Recurring numbers can either be the result of a single digit repeated or a set of numbers repeated after the comma. Very important. So in this case here, you have 3 being repeated. And in this case here, you have 1, 2, 3 being repeated. Now there's many ways that you can actually represent this. There's actually a typo here. 0.3 with the dot at the top actually represents 0.33333 and so on. 0.123, these dots at the beginning at the end indicate every number that's in between it also repeats. So basically this here means 0.123, 123, 123, 123 and so on. Or you could have a bar, like a full bar at the top, showing you all of the numbers that are repeated. So you could either represent it by a dot, right, or a dot in between two numbers showing you the set of numbers being repeated, or you could use a bar. Right, so the dots will be at the beginning and the end numbers, and everything that's in between it shows all of the numbers that are being repeated, like shown here. Right, so the bar above represents the digits repeated, or the dots at the starting digit and the ending digit. Right? That's two ways that you could see that. Okay, so now we can start talking about converting from a recurring number to a rational number. Converting recurring numbers to fractions or rational numbers. Again, what is a rational number? A rational number is a number that can be written as a fraction, and a fraction is an integer over an integer. Very important stuff. So now we're trying to convert recurring numbers, as I've just shown you, to a fraction, to get it to the form of integer over an integer. How do we do that? What I'm about to show you here is the golden piece of information. When you are trying to convert from a recurring number to a fraction, our aim is to get rid of the recurring part. What is the recurring part? It's the fractional part of the decimal. What is the fractional part? It's the part that is to the right of the comma. So we will get rid of the fractional part by finding two separate equations and subtracting. Now, I'm not too sure if you've done simultaneous equations, but this is just the very basics of simultaneous equations. But just follow the rules. Just follow the rule for now until we get to that part, which will be in the next chapter under inequalities, equations, and exponents. Right? Convert the decimal 0,33333 recurring to a fraction or rational number. Let x equal to the rational number. So x is equal to the rational number. That's step one. Multiply by a number. Now this is the crucial step, because this is where everyone messes up. Multiply by a number in order to get rid of the fractional part by subtraction. Now this would require you to think 2 steps ahead. Right? This is where we talk about thinking ahead in maths. So in this case, look here. In this case, you would multiply by 10, because if I subtract both sides, I will be able to remove the fractional part. Think of writing the recurring digits as an integer. So think about this. What's the recurring number here? Only 3. Only 3 is recurring. So if I need to write this 3 as an integer, after subtracting both this, I need to multiply by 10 to get the 3 on the what side? On the left-hand side, so that it becomes the only integer on the left-hand side. So when I subtract both of this, what happens? So if you have 3,3 recurring, right, minus 0,3 recurring, right, what's going to happen is all of the 3's that are on the right-hand side will cancel because they are the same, and you're left with only the 3. So I said that the way you think of this is you're trying to get the recurring digits to be as an integer. So you're trying to get the recurring digits to be as an integer, 3. Right? So let's do this. Let's do this example, and then I'll further elaborate when we do the next example. So x is equal to 0,3, multiply by 10. Why? Because the only digit that's recurring is what? 3. Because I want to get rid of the recurring parts. So 10x is equal to 3,3. Then we'll say equation 2 minus equation 1. Now you could do it either in the opposite way. It doesn't really matter. But you just have to be very careful with your signs. So basically, when you subtract equations, you'll subtract left-hand side from left-hand side, right-hand side from right-hand side. So it'll be 10x minus x, which is here, and 3,3 recurring minus 0,3 recurring, which is here. This and this will cancel exactly as I just showed you now. And you're left with 9x is equal to 3. Therefore, x is equal to 3 over 9, which is equal to 1 over 3. And that's how you get to your answer. Very simple. If you put this into your calculator, you would see you would get that answer. Now let's do another example. Right? Let's do another example. Convert the decimal 0,123 to a fraction or rational number. Let x equal to the rational number. Now here, watch here. I need to multiply by a number such that I can take all of these recurring digits. So what are the recurring digits? 1, 2, 3. I need to make this recurring digits go to the what side? To the left-hand side. Because when I subtract them, thinking a few steps ahead, when I subtract them, I'm going to be left with an integer, because in the subtraction, the recurring parts will cancel. Let me state that again. I am trying to move all of the recurring digits to the left-hand side of the comma, because when I subtract them, the recurring parts will cancel, and I will have the recurring digits as an integer. And watch here. Think about and here's the beauty of it. The reason I want it to be an integer is because I'm trying to convert it to a fraction, and by definition, a fraction is an integer over an integer. So all we are doing is we're trying to multiply by a number so that we can make the recurring digits an integer, so that we can get an integer over an integer, which will be in the form of a fraction. And since there's 3 digits recurring here, you multiply by 1,000. And if you multiply by 1,000 and you subtract both these equations, then you're left with 1,000 x minus x, which is 999x. And if you subtract these 2 decimals, the recurring part from here and here will cancel, so you're left with 1 to 3, and then x is equal to 1 to 3 over 999, and so on. Now watch here. I just want to show something. I just want to bring something to your attention, because a good way to explain how to do something is by showing you how not to do it. Right? So if I have to explain this in more detail, watch here, check here. Let's say you were given, because sometimes we want to do the same thing over and over because we don't understand the rules too clearly. So let's say we were given x is equal to 0,123 recurring. Then let's say you multiply by 10x because you don't really understand the idea of this rule, so you just say, no, I'm just going to apply 10x to it. So if you multiply both sides by 10x, then you're left with, if you multiply this by 10, you'll have 1,23, 123, 123, and so on. Right? 1, 2, 3, and so on. And this will continue. What's going to happen if you subtract both these digits? This is what's going to happen. On the left-hand side, you're going to have 9x. On the right-hand side, you're going to be left with, let's do this. You're going to be left with, let's do this the long way, right? So 1,23, 123, 123, 123. And then you're going to have 0,123, 123, 123. And eventually what's going to happen is you're still going to end up with a decimal, and you're not getting closer to the form of integer over an integer. Can you see that? If you put this in your calculator, 1,23, 123, 123, 123, 123, minus 0,123, 123, 123, 123, 123, 123, you are left with 1,108, 108, 108. And this is going to continue. How are you actually getting, without the use of a calculator? Mind you, you're not using a calculator. Without the use of a calculator, how are you going to get to the answer? How are you going to get to the answer? Right? So this is why the aim is to get rid of the recurring part. Right? Get rid of the recurring part. Make the recurring part an integer, so that we get closer to the form of integer over an integer, so that we're getting closer to a fraction. Right, so recurring part to an integer, recurring part to an integer, integer, because we're going to get closer to the form of integer over an integer, which will get us to the entire purpose of the section, which is a fraction. Very straightforward. Okay, so let's say you were given a much more complicated example like 0,125, 123, 125, 123. So 1, 2, 5, 1, 2, 3 is the numbers that are recurring, right? So therefore, what you do here, you would say first x is equal to that. Then you would multiply by 10, 100,000, 10,000, 100,000, 1 million. Why? Because you want all of these digits to come to the left of the comma, so that when you subtract both of these decimals, you get rid of the recurring parts. So it'll be 1 million x is equal to 125, 123, 125, 123 recurring. Therefore, when we subtract this, so we'll call this here equation 1, we will call this here equation 2. Then we'll say subtract equation 1 from 2. This is how we state it verbally. Subtract equation 1 from 2. So it'll be equation 2 minus equation 1. So therefore, we'll have 1 million x minus x is equal to 125, 123, 125, 123 recurring minus 0,125, 123 recurring. And when you subtract this, eventually this and this will cancel, and you are left with 125, 123, and you're left with 999,999 x, and therefore x is equal to 125, 123 over 999,999. And if you put this into your calculator, you do get 125, 123, 125. Now you will see a calculator will actually stop at 1, but it will go in that pattern, repeated pattern. Right? So even in an example as complicated as this, the logic follows. And this is very important, is that the theory will remain the same, but the questions will change. Theory will always remain the same, but the questions will change. So in however complex the example may be, always apply your theory, because those things never change. What's the theory? The theory is we are trying to get rid of the recurring part so that we can make it an integer. How can we make it an integer? Because we want to try to move it to the left hand side of the comma. Now remember, we spoke about that whole number part and fractional part. It's the same thing. Whole number, integers. Every whole number is an integer. Think about that. Every whole number is an integer. So whether I call it an whole number or an integer, it's actually the same thing. It's one and the same, because every whole number is an integer. So this here, we're trying to make it an integer so that when we subtract it, we get rid of the recurring parts and we're left with only an integer. And therefore, since this is an integer, we have an integer over an integer, which is equal to a what? A fraction. Right? Very simple. Very, very simple. Right? That's about it for this section.